Let's talk about index notation. What is an index notation or index form? This is index notation, or we can call it index form. So this number A, this is called base, and the smaller number here on the top right corner, this one we call it index, or you can call it power or exponent. Now let me give you 3 examples so that you know better about the index notation. 2 to the power of 3. So this one you learn in Form 1, right? I think it should be no problem. In Form 1 you learn about cube and square. So this is 2 to the power of 3, or you can say 2 cube, which is equal to 2 times 2 times 2, and is equal to 8. This one we call it index notation. And this part, this is repeated multiplication. Now let me give you a few more examples. Let's say you have 6 square. 6 square, it means 6 times 6, which is equal to 36. This is index notation, and the 6 here is a base, and the 2 here is a power or index or exponent. Now it looks very simple, right? But sometimes some students might make some mistake. For example, let's say 6 to the power of 2. They will think that this is actually 6 times 2, which gives you 12. This is not correct. 6 to the power of 2, it means 6 times 6, not 6 times 2. Okay? Now, when you have a negative number or fraction, you need to be extra careful. For example, negative 3 to the power of 4 compare with negative 3 to the power of 4. This one with parentheses, this one without parentheses. Their value are actually different. So for this one, the power 4 is only for 3, not for 1. Not for the negative. So means that the negative just 1 time, but 3 repeated 4 times. 1, 2, 3, 4. So the answer is negative 81. How about this one? Now you'll notice that this one, you have a parenthesis here. So this parenthesis telling you that the negative and 3 whole thing repeated for 4 times. So it will be negative 3 times negative 3 times negative 3, and one more last time. So okay, so the answer will be 81. So do you notice that they actually mean differently? That's one, the negative only 1 time, and this whole thing repeated for 4 times. So you need to be more careful when you have a negative sign. So how about fraction? So for example, 2 over 3 power 3 compare with 2 over 3 power 3. So these two also mean differently. So if you write like this, people would just assume that the 2 to the power of 3, 2 is raised to the power of 3, which means 2 times 2 times 2, or we can say 2 cube. Oh, sorry, this is not, should be 2. And the 3 only 1 time. So the answer will be 8 over 3. Whereas for this one, you have a parenthesis, so people know that this whole thing repeated for 3 times. So 2 over 3 times 2 over 3 times 2 over 3. So the answer will be 2 times 2 times 2, you will get 8. 3 times 3 times 3, you will get 27. So you need to be more careful for this one, especially when you have a negative sign. Okay, let's try decimal. Same thing apply here. 0.2 to the power of, let's say, to the power of 4. Compare with negative 0.2 of this one. Let me add a negative for it. To the power of 4. Okay. Same thing as we discussed just now, this one without parentheses, this one with parentheses. So without parentheses like this, it means that the negative only one time, and the 0.2 repeated for 4 times, because power 4, right? You can press your calculator to help you to get the answer. If you don't want to use your calculator, you can just think about 2 to the power of 4. 2 to the power of 4 is equal to 16, right? So you can just write 16 first. And then you have 1 decimal place here, 4 times, then you will be 4 decimal places. 1, 2, 3, 4. Okay. So the answer is negative 0.0016. You can always check by using your calculator. So how do we key in to the power of 4? Negative 0.2, this button, to the power of 4. Okay, so the answer is negative 0.0016. So how about this one? Let me copy over here. Negative 0.2, but this time you have a parenthesis over here. So this actually telling you that the negative is actually involved in the process of power of 4. So the negative are repeated together with the 0.2, which means you will see 4 times negative 0.2. Okay. Okay. Let me make this one smaller. So what is this answer? So the negative to the power of 4, this will become positive, right? Because this is even power. So we can just forget about the negative sign. So just think about 0.2 to the power of 4. You will get 0.0016. Now if you want to press your calculator, remember this one you have parentheses, so you need to key in parentheses first. Negative 0.2 to the power of 4. Okay, so the answer is 0.0016. So you need to be more careful when you have a number to the power of 3, 4, 5 and something. When you have a negative, you need to be extra careful. Now let's try this question. We want to write each of the following number in index form or index notation using the stated base in the bracket. Okay, now 243. We want to write this 243 in index notation. Index notation is this, right? Okay, and we need to use a base of 3. So what should we do? You can use your calculator to help you, or you can do it this way. Since we want to use a base of 3, what do I need to do is keep on dividing this number by 3. 243 divided by 3, you will get 81. 81 divided by 3, 27. 9 divided by 3, you get 3, and until you get 1. 3 divided by 3, you get 1. How many times of 3? 1, 2, 3, 4, 5. So this is actually equal to 3 to the power of 5. So there are a few ways you can use a calculator to help you to check the answer. First one is try an error, for example. Now 3 to the power of what is equal to 243. Let me take a try. Let's say maybe I key in 2, for example. Oh, it's not correct. Then let me change it. 4. Oh, not correct, still not correct. So let's try 5. Okay, so this is the answer that we want, 3 to the power of 5. This is try and error method. So another method is, if this is a prime number, 3 is a prime number, right? We actually can use a prime factorization function of this calculator to help you to get the answer. Now, first you key in 243 and then press equal. Now I'm going to use a prime factorization function of this calculator to help me to get the answer. Press shift first and then press this one. 3 to the power of 5. Okay, now how about B? 625. We want to write in index form or index notation using the base of 5. Since I want to use the base of 5, what should I do is take the 625, keep on dividing this 625 by 5. If the number is a little bit big, hard for you to calculate mentally, you can actually use a calculator to calculate, or you can do it this way. Just like what you did in primary school. Okay, this is 125 divided by 5. Keep on dividing this number by 5. Why? Because we want to use the base of 5 until you see 1. How many times? 1, 2, 3, 4. So it will be 5 to the power of 4. Okay, now we have a negative number over here, and the base that we need to use is negative 2. So it means that negative 2, okay, remember this is the base, so I need to put a parenthesis over here. So this whole thing need to multiply itself how many times so that we get a value of negative 8. So we know that before we calculating, we know that the power must be an odd number, right? Because if this is an even number, the answer will be positive. So we know here must be an odd number. So you don't need to do like this. If you do like this, it will be a little bit hard. For example, now negative 8 divided by negative 2 is equal to 4, positive 4, because negative become positive. And then 4 divided by negative 2 is equal to negative 2. Positive divided by negative, you get negative. And negative 2 divided by negative 2, you get positive, right? Positive 1, right? So it's equal to negative 2 to the power of 3. So I feel that this will make you a little bit, make us confused, because it will become positive, then negative, keep on changing the sign. So you can just do it this way. For 2, you get 8. 2 you get 4. Okay, 1 times 2, you get 2. So 3 times, right? But here you need to write negative 2. Why? Because the base that asked from the question is negative 2. So we need to follow the requirement of the question. Okay? Or you can use your calculator to check. Negative 2 to the power of 3. Negative. If the power here is even, definitely it will become positive. You see? But without parentheses, that will be different. Now, even though the power is even, but without parentheses, it means that only 2 to the power of 4. The negative is not affected. So the final answer will still be negative. You see? Okay, now let's go to part D. Now we have 64, and the base that we want to use is negative 2, same as what we did just now, negative 2. Negative 2 to the power of something. Before I calculate, I know that the power must be even. The number here must be an even number. Why? Because this is negative. Here must be, it must be an even power so that it will become a positive number. You get what I mean? Now, so what should I do is, you can do it this way, but I think it's quite confusing. So what I'm going to do here is, I forget about the negative, I just write 2. So 64 divided by 2, you get 32, right? Keep on divided by 2. Okay, 4, 2, 8, 2, 2, 4, and 2 divided by 2, you get 1. 1, 2, 3, 4, 5, 6. 6. You can press your calculator, it's correct, this is an correct answer. And remember to put parenthesis, negative 2 to the power of 6. 64. If you do not put a parenthesis, the answer will be different, which is negative 64. Now let's try this one. This time we have a fraction over here. And the base that asked from the question is 3 over 4. Don't forget, this is base, right? Remember to put a parenthesis. So now, do you have a fraction? How do we do this one? We do not do it this way because this will be quite confusing. We do not do it this way. So you can just think it this way. Because the 3 and 4 will raise to the same power, which is equal to 27 over 64, right? So you just look at the small number. So forget about the 64 and 4. You just focus on these and this. What you need to do is to find 3 to the power of what will give you 27. 27 divided by 3, right? So 9 divided by 3, 3 divided by 3, you get 1. So we know that 3 to the power of 3 will give 27, and the power here is shared. So 4 to the power of 3 definitely will be equal to 64 as well. Now you can check your calculator. 4, use a calculator to help you check the answer. 4 to the power of 3, see, 64. If you want to key in this whole thing, 3 over 4, remember put a parenthesis, to the power of 3, yes, is equal to 27 over 64. Okay, so this is a way how we write this fraction in index notation. Now let's try last one. F 0.1296. The base is 0.6, so to the power of something. So before calculating, I know it's actually equal to 4. Why? Because now if it has 1 decimal places, so multiply with itself how many times so that you get 4 decimal places. So definitely this will be repeated for 4 times, right? So that you will get 4 decimal places is equal to 4. Now, but I still can check it this way. Since this is decimal, right? You don't have to write this because it's quite confusing if you do it this way. So just take 1296 divided by 6. 2. Okay. 38. Okay, 4 times, right? Now we can, but here you cannot write 6 because the base is 0.6. Okay, now let's try using our calculator to check our answer, whether this answer correct or not. 0.6 to the power of 4. 0.1296. So this is the way how do we write a number in index notation, by using the base given by the quotient.